Welcome back, everybody, to section 2.5. This is part 2. We're talking about domain and range. Domain and range is kind of like the Achilles heel of a lot of students. It's really not that bad, though. The domain is simply the set of all x values. I don't know why I put a hyphen there. No hyphen. So it's the set of all x values. On the flip side, the range is the set of all, I should write all possible y values. I'm going to write that for the x2. Just plop a possible in there, please. Thank you. Okay, so as we're evaluating these different functions, we're just going to look at all the possible x values and all the possible y values. Okay, this is kind of irritating me that the x values are in blue and the y values, so check this out. For all of you at home, make sure you try to get Notability. If you like taking notes and you're virtual, I highly recommend Notability. I'm not even sponsored by them or anything. I just really think it's a great product for taking notes. Clearly, I mean, talked about Notability, that's the name of it, but anyway, I'm just do a quick change here, change this to red. I'm sorry if yours is not like that, if you're following along with my notes, but that's the way it's going to be. So the domain. The domain is all the possible x values. So what we're going to do here is we're just going to create a little bracket, okay, and then we're just going to write all the x values, okay, and I'm going to label them here, x, 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 and we have 1, comma, -2, comma, 3. Those are all the possible x values. There's only 3 of them, okay. Now the range, all the possible y values. So we write the y, 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 okay. Again, plop a bracket down. We have 2, comma, 4, comma, -1. Oops, this bracket sucked. Stunk. So we have 2, 4, and -1. That's our range. So that's pretty simple there, and this is not your typical problem, but it's just an introduction saying that those are the y values and those are the x values. Example 2, what is the domain and range in the graphs? Okay, this one gets a little bit more complicated because we first need to label all the points. Okay, let's label these points with their x and y values. So just trying to find the location of each one of these. Whoops, not sure why I did that. I was just talking you up, Notability. Okay, need to back it up here, back it up, go to the grabber, there we go. Okay, back in business. Okay, so this one is negative, let's see, 1, 2, 3, 4, 5, -5, comma, -2. That's that point. 1 down, then we got -2, comma, 2. 2 down, then we have 2, comma, what is that, 6? 2, comma, 6. Okay, 3 down, we got 1, 2, 3, 4, 5, 6. This is 6, comma, 5. And then we have this last one, which is 4, comma, -1. Okay, so we have 5 different points here. So we're just going to consider, again, the x values and the y values. So these are all the x values that we're going to consider. It probably makes sense doing it in increasing order. So we're going to write -5, -2, 2, 4, and 6. Those are our possible x values. Those are the only x values because our function is only consisted of those 4 points. Again, we're going to go from lowest to highest here. So we're going to go from -2 to -1 to 2 to 5 to 6. Okay. Now this is really important. This is something my students really struggled with last year, is identifying the extremes of the graphs. Okay, what do I mean by that? Well, I'm going to start with showing you the extremes of, the left and right. So I've got my little, I don't want to do this. Sorry, getting a little picky here. Make this pretty big. Okay, so I'm going to grab this and I'm going to move it around. Now, what am I going to do with this? Okay, so as you're talking about the domain, you're talking about the leftmost point on the graph, the leftmost possible point to the rightmost possible point. Okay, it's the set of all values from left to right with the domain. Okay, so domain, we're thinking left to right. The furthest point is -5, and then we had -2, obviously, 2, 4, and 6. So we went from -5 all the way to 6 with only those points in between. Not all values in between those, but those are the 5 that we're talking about. Okay, so we use that for our domain. Now, with our range, it's different. We're talking about the lowest point to the highest point. Okay, So let me lock that in there. So we're talking about our lowest point, and you have to be able to identify this. Our lowest point is -2 for the y. And then we had -1, then we had 2, then we had 5, and then we had 6. If you can separate every graph and every function vertically and horizontally for your domain and range, it's going to be much easier for you. So that's my little tip. Maybe get like a ID, a credit card, driver's license, and use that on your paper to go from left to right for the domain, and then from down to up, low to high for your range, and that'll make it a little bit more visual, a little more kinetic for you to understand that a little bit better. By the way, this is set notation. Anytime you have these squiggly brackets, that is set notation, like that. Okay, moving on to example 2. So our domain. Okay, I'm going to go grab these. These were pretty useful. I'm going to take these. Doom, doom. Here we go. Okay. So what is our domain and what is our range? Now, it's not just points. So we're not going to have just values of x. We're going to have a kind of a span of values. I don't want to say a range of value because range we're reserving for the possible y values, but we're going to have an interval here, okay? Because there's an infinite number of points between 0 and 1 even, okay? So let's start with our domain. With our domain, what is the furthest left point, okay? This is the furthest left point on the graph. See how it locks into place there? Let me zoom in a little bit, okay? So our furthest left point is where? On -4 for x. So on this x-axis, we're looking for the furthest left point, and that is -4. Okay. Now there's points everywhere. There's a point at -3.9. There's a point at -3. There's a point at -2.5, -2. Okay. At 0, there's a point. There's a point there, and there's a point down here. Okay. All over the place, up until we get to +1, 2, 3, 4, 5, 6, and then there's no more past 6. So from -4 all the way to +6 for the x values, okay, that's our domain. How do I express that? Well, we can say the x values go from -4 to 6, okay? Or if we're using these brackets here, not the squiggly brackets for set notation, if we're using these ones, we can say -4, comma, 6, and that's supposed to be arrow, okay? That's a way to say that this is the one on the left is the lower limit, and the one on the right is the upper limit. We did this earlier too. I forget what's in the chapter 1 we did this, but that is our upper limit. Another way to express this would be interval notation, and we could say -4 is less than or equal to x is less than or equal to 6. So there's two different ways of saying the domain here. This one's a little bit easier in this bracket notation. So yeah. You can pick, but I'm just saying this one's a little easier. Okay, range. Let's talk about that real quick. Again, we're going to get our little bar here. If you want to use your ID or a ruler, that's great. So we're going to start from the lowest point. Always start at the low to high, left to right. Okay, so lowest point here is -1, 2, 3, 4, 5, 6, 7, 8. So we went from -8 all the way to +1, 2, 3, 4, 5, 6, 7, 8. Okay, we went from -8 to +8. Okay, and there was no breaks in the line. Notice how there's no points on the line that are not included. That means it's a solid, continuous inclusion between -8 and +8. Okay, and that is interval notation. Okay, so then this is, I think I said that this one was interval notation right here, but that's more like inequality notation. This one's interval notation. I had it right in front of me, I didn't even say it. Again, lower limit on the left, upper limit on the right. Okay. Okay, and when I say upper, that means up, and lower, that means down. For domain, it means to the right and to the left. Okay, so for domain, it's, let me draw this out. We go from left to right. For domain, we go from down to up. Okay. All right, let's go do the next one. I'm going to grab these guys. I'm going to just keep using them. These tools are so useful. Okay, so grab this guy, move him down over here. Okay. Domain. Okay, we're going to go from the lowest, the furthest left extreme to the furthest right extreme. So we're going to grab this guy. Okay, we're going to grab him, and okay, so we encounter something. We encounter an arrow. Okay, so notice that it was going left, 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 still going left, and then we have an arrow. If we're going left, trying to get to our endpoint, and we see that there's an arrow as we're going left, what does that mean? That means our domain is going to be, and if I need to put parentheses here, I'll tell you why in a second. Our domain is going to be negative infinity. Okay, it can never be equal to negative infinity. That's why I include the parenthesis and not the bracket. Please see chapter 1. Parentheses essentially mean less than or greater than. Brackets mean it can be equal to it or greater than or equal to it. And since infinity you can't be equal to it, you have to use the parenthesis. Okay, so again, there was an arrow to the left. So that is why it's going to go to infinity to the left. And as I go here to the right, notice as I'm going to the right, there's an arrow, which means it continues. It's going to continue to infinity and beyond, Buzz Lightyear style. So we have positive infinity on the right. The range is not going to be like that, okay? So as we look at the range, we're going to start from the lowest extreme. So there's nothing down here, nothing, 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 there's something, okay? So at -3, there was something. So we know that -3 is our lower limit. Can it include -3? Yes, there's a blue line there. It's not infinity, and it's not an open dot or a dashed line. So it is going to be -3. That is, oops, we used blue for range. So it's going to be -3 for our lower limit, comma. What is our upper limit? Well, as we continue to go up, 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 we see arrows, which means it continues for infinity. So we're going to put infinity, but keep in mind it can't include infinity, so we need to put parenthesis. Okay, we put a bracket because it included -3, but we put a parenthesis because it couldn't include positive infinity. Another way to express this is all real numbers for x. You could write it like this. Okay, a couple different options there, but for your domain, it would have to look like something. Y can be equal to -3 or greater than. Okay, so that would be one way to write it, or you could also write it like this. Oops, I didn't mean to do that. Like this. Okay, I call this the sandwich. The sandwich really translates well into the interval notation, so I recommend the sandwich to anyone that wants to learn how to do interval notation, but either is fine. Okay, the vertical line test. The vertical line test is a way to determine if something's a function, but guess what? I'm going to get to that in part 3 of this video. This is a long section. Thank you for sticking with me so far, and I look forward to seeing you in the next video.